There are three states of matter: solid, liquid, and gas. It's easy to study the properties and behavior of solids and liquids. But when it comes to gases, it's a challenge. Even as you're sitting right now, there's air around you. If the fan is blowing, so you can feel air, but you cannot feel still air. Like air, most of the gases are colorless. So to study the properties and behavior of gases is a challenge. Some brilliant scientists took this challenge. We'll see what they studied, but right now, let's recall some of the characteristics of gases. Gases, the particles of gases are always in a state of constant motion. So as they're moving, they're colliding with one another and with the walls of the container in which they are enclosed. So we have solids, liquids, and gases. The particles in all the three states are in a state of constant motion. But in solids, the particles vibrate about their mean positions. The interparticle space between them is minimum, and the interparticle force of attraction is maximum. In liquids, the interparticle space is more than solids, and the interparticle forces of attractions are weaker than solids. In case of gases, the particles are wide apart. The interparticle spaces in gases is the maximum, and that is why the interparticle force of attraction or the intermolecular force of attraction in gases is minimum. Gases have a tendency to mix with each other. If a person is applying perfume in one corner of the room, you can get the fragrance standing on the other corner of the room. How is this possible? This is possible because, say, if this is the perfume bottle, these are the particles of the perfume and these are the air particles. So as we open the bottle, the particles of perfume, as they are in the state of constant motion, like the air particles, they mix with the particles of air. So as a person standing in one corner of the room applies perfume, the particles of the perfume travel across the room, they mix with the particles of air, and this is how you are able to smell it. Gases do not have a fixed shape. They take the shape of the container in which they are enclosed. So whatever the shape of the container be, they take the entire space of the container in which they are enclosed. Do gases have definite shape? Is it true or false that gases have definite shape? We know that gases do not have definite shape. They take the shape of the container in which they are enclosed. So let's see. Here we have a pump. When it is pressed once, it releases some amount of gas. One press of the pump releases equal amount of gas. So the first time we'll press the pump, we allow the gas to pass in this container. Let's see what happens. So as it is pressed, it releases 2 grams of gas, and this gas occupies entire volume of this small container. Now, if the same amount of gas is made to pass in this or is released in the bigger container, you observe that the amount of gas which is same, that is 2 grams, it occupies the entire volume which is available to it. So in the first case, the gas occupies the smaller volume. In the second case, it occupies the volume of the bigger container. So from this, we see 3 properties of gases. Number 1, gases have definite mass. As the pump is pressed one time, it releases 2 grams of gas. Similarly, in the bigger container, it is pressed once, so it releases the same amount of gas, which is 2 grams. So gases have a definite mass. Secondly, in the first container you observed, as the gas is released, it takes up the entire space which is available. So in the first case, this is the volume of gas. In the second case, this is the volume taken up by the gas. So gases do not have a definite volume. They take up the volume of the container in which they are enclosed. And thirdly, they do not have a definite shape. In the first case, they take the shape of the small container, and in the second case, they take the shape of the bigger container. So these are some of the characteristics of gases.